Chromosomal disorders. We've talked before about genetic disorders affecting particular genes. This time we're talking about entire chromosomes or chunks of chromosomes. So how could this happen? Non-disjunction. Non-disjunction is where you have one too many or one too few chromosomes because they just don't divide correctly. Aneuploidy is an abnormal number of particular chromosomes. So there's two types of these we're going to talk about. The first is when you have one too few, and that's called Turner syndrome, or the only viable monosomy in humans is Turner syndrome. This affects only the sex chromosomes. If you have Turner syndrome, you're phenotypically a female, but you only have one X, so you don't develop secondary sex characteristics. With estrogen therapy, you can. If you have one too many, that's called trisomy. Trisomy 21 is known as Down syndrome. That's when you have an extra chromosome in the 21st set of chromosomes, and that extra chromosome is responsible for all of the characteristics that go along with Down syndrome, like characteristic facial features, short stature, mental retardation, being more prone to leukemia and Alzheimer's, and even like respiratory infections and things like that. If an individual has Down syndrome, they can live to be middle-aged and sometimes even older, but it still is a shortened lifespan. Most trisomies increase with maternal age, so the older the mom is, the higher the increase that a trisomy will occur. Most trisomies of these other autosomal chromosomes here, the child doesn't live to be very long. Trisomy 21 is the exception, and then these trisomies of the sex chromosomes. Klinefelter syndrome, the individual is phenotypically male, but they have an extra X. The extra X is inactivated, but it still has an effect on the individual. They tend to be sterile and have abnormally small testes. They can also have, it's also common to have female characteristics like enlarged breasts. Having an extra Y does not have that same effect. It actually doesn't affect the individual much at all. There's no well-defined syndrome. The only trend that you can even see is that sometimes these guys are taller than average. Remember, average for male is 5'10". If you know someone who is very tall, don't go tell them you think they have a chromosomal disorder because of their height. That's rude. People don't like it. I wouldn't bring it up unless a student had already done it. Same with women. If you have trisomy of that X chromosome, there's no way to know unless you get this karyotype done. So these two have really no effect on the individual. Polyploidy is when you have extra sets of chromosomes. So instead of like 2n plus 1 or 2n minus 1, like we'd been talking about with that one extra chromosome, you're having 3n, 4n, 8n in strawberries. This does not happen in humans and be able to have a viable offspring, but it's fairly common in plants. You can have pieces of chromosomes either get lost, like in deletion, get deleted but then reattached in the sister chromatid in duplication. It can reattach in the opposite order, which is inversion, or translocation where it attaches to a different chromosome, a non-homologous chromosome. Cri du chat is cry of the cat. These babies don't live very long. They usually die in infancy. Give me just a second. I'm almost done. They have abnormally small heads and unusual facial features, and when they cry, it sounds like a distressed cat. The other example here, CML, is chronic myelogenous leukemia, and that's when you have a large piece of 22 and a small piece of 9 attached to make a very small 22. There are some other inheritance patterns that are exceptions. Genomic imprinting, where you actually have a silencing of one allele. And this, so you have one trait that's either going to be inherited just from mom or just from dad. This was found, the first example is the insulin-like growth factor 2. It was found in rats. Only the paternal gene is expressed, and you need this growth factor to for correct prenatal growth. The way genes are activated or inactivated has to do with adding methyl groups to them. And lastly, the inheritance of organelle genes. Remember, not all genes are in the nucleus. Some can be in the cytoplasm or within other organelles, as is the case with mitochondria and chloroplasts. They have a single circular piece of DNA, just like bacteria. They reproduce themselves and transmit their genes to daughter organelles. So mitochondrial DNA is going to be a big deal. It's passed only from mother to offspring because all of our mitochondria mainly come from the egg. The egg has unequal cytoplasmic division during egg formation, and the sperm's trying to stay as light as possible. So there are certain conditions you can get from your mom. She'll pass it to all offspring. Mitochondrial myopathy, Leber's hereditary optic neuropathy, where you lose sight by like your 20s or 30s. And in some cases, mitochondrial DNA may also contribute to diabetes and heart disease, as well as Alzheimer's. Remember that new mutations are always accumulating in your body and may play a role in the normal aging process.